So this lesson, starting on page 37, is meant as a practice lesson. So I would recommend trying these proofs on your own and then coming back and checking. So if we're given that BC is congruent to DC, so BC and DC, this is why you have to pay attention, because sometimes they're not exactly what you would think, right? We're used to saying like, oh, like these two parts would be congruent. No, in this case it is BC and DC. And then the same thing with AC and EC. So right away, I have two congruent sides. I have intersecting lines. So I know that I'm going to use side, angle, side, and get that middle angle by vertical angle definition. So I write out my given. I want to state that the angles are vertical by the definition of vertical angles. Then the angles are congruent because vertical angles are always congruent. And then I can say that the triangles are congruent based off of side, angle, side. It is side, angle, side because it is sandwiched. The sides are on either side of the congruent. Next one. Again, we need to mark everything that we have. We have a pair of congruent sides. So AY is congruent to BY. We have a set of congruent angles. And then we know that Y is a midpoint. Definition of midpoint is that it creates two congruent segments. So I can see based off of this that I am going to use side, angle, side. Write out your given. All you have to do here is state that XY is equal to YZ by the definition of a midpoint. And then you have enough to use side, angle, side to state that the triangles are congruent. This worksheet likes to give you more lines if you wanted to write out the givens as each separate line, but my preference is to write them all in one just for the sake of time. Now, this is something that we haven't really talked about, but if you look, it says that the triangle is isosceles. You guys should know isosceles means that there are at least two congruent sides. So it tells us that the legs are RT and TS. So that tells us that RT is congruent to TS. Now that I look at my answer key, that should also be in there. So you would have that RT is congruent to TS by the definition of isosceles triangles. So there should be an extra line in here. You're also given that Q is the midpoint. So you know that RQ is congruent to QS. I have two sides. I don't see anything about angles, but I know that there is a shared segment, so I can use reflexive to get side, side, side. And then the last one on this page, angle P is congruent to angle N. I can, even before reading the rest of the givens, I see vertical angles here, so I know that's going to be a part of my proof. And M is the midpoint of PN. So I know that I have congruent segments that I'll have to declare. So then I'm going to have an angle, a side, and an angle all sandwiched. So I'm going to use angle, side, angle. Because I also missed this. So in this proof, you should also add that PM is congruent to MN by the definition of a midpoint. This should be included in your proof before you state that the triangles are congruent. First one was an example. I believe there was a typo up here, but if we're giving that GH is congruent to HIH, so we have a pair of congruent sides. GF is congruent to, it should be GF is congruent to FI. Yeah, I don't know why. And then we're going to use reflexive to get our third side. Yeah, this problem is very messed up because if you look, they're saying with the prove. Yeah, very odd notation. I didn't pick that up when I was doing the answer key. Clearly, Miss D'Souza did not drink enough coffee before doing her answer key for this section of the packet. Okay, so here we have parallel lines. If you look in the front of your packet, there is a glossary that goes through all of the relationships of angles in parallel lines. So if ST is parallel to RU, I know that T and R, that these two angles here, STR and TRU, are congruent by alternate interior angles. I also know that RT is congruent to itself by reflexive, and you're given that these two angles are congruent in the given. So I have angle, angle, side, therefore my triangles are congruent. So on the next page, they have some parts filled in and ask you to fill in the rest that is missing. So you have to fill in that C is the midpoint of BE and AD. Okay, that is given. They tell us that BC is equal to EC based off the definition of a midpoint because C is the midpoint of both of those lines. By that logic, you're then going to follow in with the other line that's saying that DC is congruent to CA since C is the midpoint. Now, they put it in one line. I like to do it in two, but you're going to state that ACD and DCE are congruent because they are vertical angles, and vertical angles are congruent. We have a side, an angle, and a side sandwiched together. So we use side, angle, side to state that the triangles are congruent. Here we're given that BC is congruent to DA, so I mark it. Then I know that AC bisects the angle BCD, so I have a pair of congruent angles here. And I can see that there is a shared side, so I'm going to use reflexive. I will then be able to say that these triangles are congruent by side, angle, side. So start filling in what was given. Here they give us the angle symbol, so we know that I have to fill in that angle BCA is congruent to angle DCA by definition of a bisector. AC is congruent to AC, reflexive, and therefore the triangles are congruent by side, angle, side. Number 3, angle X is congruent to angle H. So I marked it here, so I have one pair of congruent angles already. And then again, this is the symbol for parallel lines. I like to use alternate interior angles, so I'm going to mark that angle XGF is congruent to angle HFG by alternate interior angles. This is 3 that you're going to state. And then to get our final piece of information, there's a shared side, so I'm going to use reflexive, so that way I can get angle, angle, side. The side is not in between the angles, so it is angle, angle, side, not side, angle, side. Nope, angle, angle, side. I'm going through these rather quickly because you should be trying these on your own and just using this as a reference. Hopefully with the things being filled in and you're just filling in the pieces, it's easier to see sort of the logic and the way that these are set up. So here's a little bit different because they're not writing out the given statements. They're sort of giving it to you in the diagram, so you have to interpret the diagram. This isn't very common when it comes to geometry questions, but it is good practice to make sure you understand the notation. So here they wrote out the given statements because you know that LM and LO, because you see the 1 tick mark. 2 tick marks tell us that these are congruent. All I need to finish this is 1 extra side, which I can get via reflexive. So here they are telling us that these lines are parallel. That's what the little arrow means. right? They're also telling us that these angles are congruent. They look like right angles, so you might be tempted to use something you know about right angles, but it's even easier than you might think, because if we use alternate interior, we now have two sets of congruent angles and a shared side using the reflexive. So we can use AS, angle, side, to state that the triangles must be congruent. So again, we can see here I have pairs of congruent sides. We should be used to this by now. These angles are vertical, therefore they're congruent. Side, angle, side. Now we have two pairs of parallel lines. So you're going to use alternate interior angles on two sets. So angles 1 and 4 are alternate interiors, as well as 2 and 3. So I have angles all over here, right? So I can say angle, side by reflexive. Okay, one more page. Then the last page I gave you for homework, so I'm not going to go through that. Or I should have given you for homework, or I'm planning on giving it to you for homework. You guys know by now, Miss D'Souza sometimes goes off plan. Alright, so again, our given statements, angle I and angle K. We have these guys. So we have angle, and you guys should see the easiest way to do this is to use the shared side via reflexive, and now we have angle, side. We're given two pairs of congruent angles. They didn't name it for you here, so what you had to do is you had to use the fact that OLN has 2 marks to state that MNL would be the corresponding congruent angle, and then again, reflexive, state that the side is congruent to itself. But here we have angle, side, angle. It is sandwiched, so we're going to use angle, side, angle in this proof. Once you guys see this setup, the very first thing you should be thinking by now is that there are vertical angles, which we see here. You also need to fill in the other piece of given information based off of the drawings in the diagram. So PQ is congruent to QS. They wrote that, and you can see it with the 1 tick mark. The other 2 are congruent because they have the matching 2. So TQ is congruent to QR. So I have a side, an angle, and a side. Therefore, they are congruent triangles. So this one requires a little bit of knowledge about isosceles triangles. We have not specifically gone over it because it is not a common theorem that we use a lot. But if you know about isosceles triangles, this proof should not be that difficult. And also, since they wrote it out for you, you should be able to figure it out based off of your knowledge. So they give us that UV is congruent to UX. So that right there tells you that this is an isosceles triangle. They also tell us that VWU is congruent to XWU. So we have a pair of congruent angles here. There is a reflexive side. Now the reason why we cannot simply say, oh, well, I have a side, and an angle is because this is not a valid theorem for triangle congruence. So I need to find another way. So if you know that the legs of a triangle are congruent, then the opposite sides, the base angles of a isosceles triangle, are also congruent. So that's how we're getting that angle V is congruent to angle X in line 4. So again, the base angles of an isosceles triangle are congruent. This lets us use angle, side for line 5. And then finally, problem 9. Again, you see the crisscross, you know vertical angles are coming. So we're given a pair of congruent angles, we're given a pair of congruent sides, and we use those vertical angles to state that the triangles are congruent by angle, side, angle.